Okay, here we go. Right, so hi, I'm Miles Murray. I'm Professor of Computing Education at the University of Roehampton, where my day job is training the next generation of outstanding teachers, one of which is exemplified. I brought some of my work with me. Lovely. They let me out to do other things, so I've been involved with CAS since the very, very early days, when CAS was just like people who signed up for a Google group. There are people in the room who are old enough to remember Google groups. Those are the days, really, yes. And I'm still involved with CAS, and it's just lovely to come together as a community, as I think many of us are feeling at this. The slides are all online, so those of you who suffer from insomnia can just watch the slides all over again later. So, straw poll, folks, yes? In primary school, most kids learn to code using a block-based language, Scratch Junior, then into Scratch. There are other block-based languages available, I know, but it typically is one of those, it is those two in that order. By the time they do their GCSEs, poor things, many of them have to do OCR exam reference language. If they stay on and do A-level, they will be doing a non-exam assessment in a text-based language. So somewhere between the age of 11 and the age of 14, we move them from working with blocks to working with text as their medium for coding. We have to choose, don't we, yes? Do you favour the view on the left? Use block-based languages for as long as possible. Hands up. This is going to be a tough sell this afternoon, isn't it? Or do you favour the choice on the right to get them used to Python or text-based languages as soon as possible? Okay, I've got a number of people who appear to reject my false dichotomy and say, oh, it is to be both, Miles, yes? Okay, what do you think?
Yeah, I think they should move.
Yeah, okay, and it is interesting that this audience favours that particular perspective, yes?
I feel like when you're working with them, they realise that text is quicker than blocks sometimes.
Oh, yes, absolutely, yes. And, you know, when is the right time to move? Perhaps you want to take a much more sort of trendy educator perspective and say, when the child is ready for it. And there is a view that actually does make sense, that sooner or later, 640 by 480 pixels is not enough resolution for their amazing idea, or they just get so fed up of, snap, and actually want to type. So yeah, let's just listen to the kid and say when they're ready might not be an entirely crazy idea. Yeah.
I think the platform makes a big point around this because we use EduBlocks in year 7.
Yeah.
And we present the worksheet tasks using blocks, but we show, of course, that you've got the text space on the right. And we say when you're ready, you can go straight to the text.
And this is where I'm heading in the last half hour of this, so bear with me. We will get to the shiny toys, okay?
I don't think we should be teaching programming in stage 3 at all. I think we should be focusing on computational thinking, focusing on basically actually the big one when talked about going from the intent to the specification.
So will you allow me to show my next slide? So, yeah, what do you want of your kids? Do you want them to be the architects of the future, of having the computational thinking, the grand idea of what it is? Or do you want them to be the future bricklayers who can actually just build the thing? And here you all must reject the false dichotomy and say, it's not an either-or situation, Miles. They really do need to have both sets of skills. Architects without bricklayers would be sculptors. No, they wouldn't even be sculptors. They would just be like drawers or something, yeah? Bricklayers without architects. I don't really want to go and live in that house or work in that office. I think there needs to be a plan that one has in mind. And so the both and, I think, is a big part of this. Go on.
So what about the impact of AI?
Yeah, if I ever get to the last slide, we have got vibe coding coming up at the very, very end of this. The chance of getting here is quite slim, the way things are going so far. Right. So look, we know the computational thing is the argument, isn't it? Anybody who thinks we put coding onto the curriculum so kids would be able to get jobs as software engineers, you did not read the memo. You really didn't, yeah? This is a way of solving problems. It teaches a certain sort of tenacity. This is about understanding some of the greatest things which our civilization has built. This is not about getting a job as a software engineer. This is about a systematic way of looking at problems. Rightly so. Nevertheless, Simon's national curriculum says, as one of the overarching aims, can analyse problems in computational terms. That's fine, and have repeated practical experience of writing computer programs in order to solve such problems. It's not as clear in the statements in the program study, the content, but it's there right at the top. Repeated practical experience of writing programs to solve problems. That's the point of teaching programming. It's there in top level of the national curriculum. I'll give you a moment to copy down the diagram from the slide or take a photograph of it. So this is hard because when you're programming, you're holding too much in your head at once. There's a whole load of syntax of what is the command for. Is there a bracket after the print statement? Where is it a colon? Do I have to indent it? Is it 2 spaces or 4 spaces, or does it even matter? There's a load of the technical specification of the language. It's really hard. And then there's the semantics to this, is what does my program even have to do? How am I going to solve this difficult problem? Holding both of these things in your head at the same time, teacher training people, limited working memory capacity, cognitive load and all of that, this is really difficult because at their age, at their stage, Python is not a language in which they have fluent mastery. They have to think about the command. They have to think about the syntax. And that really restricts your opportunity to do all of the semantic thinking, which at least 2 of us think is what really matters in all of this. I feel I ought to, being as we're at the CAS Conference, reference the Bohm-Jacopini theorem. As you're all very familiar, I'm sure, this states that as long as you have a language which has sequence, selection, and repetition, it is Turing complete. And of course, the Church-Turing thesis, which says that if there is a problem which you can solve using a computer, then a Turing machine could be made to do that. It's all equivalent to making marks on tape, as long as you have enough tape. Getting the tape is really difficult these days. My point of the theoretical computer science here, any problem you can solve with a computer at all, you can solve in a Turing-complete language. And apart from the lack of tape, Scratch is a Turing-complete language. There is no problem which you need Python or Java or Haskell to solve that you can't solve by writing lots and lots and lots and lots of Scratch code, yeah? They've learnt it all by the end of primary, broadly speaking. They may be able to do cooler things, and, 480 by 640 pixels is an issue with that. Okay, so what are the convincing arguments for going with the block thing? Oh, for pity's sake, folks, they do not like your subject. Beg pardon, they do not like our subject. They come into primary school, 2/3 of them find that this is an interesting or fairly interesting subject. By the time they get up to year 11, those who are still with us, only 1/3 of them find this interesting or fairly interesting. So what have you done to these poor kids in their time in secondary school? Why has this gone wrong? I'm not saying it's all because of Python programming, but I think some of it might be because of Python programming. That in primary school they get to make games, and they get to make cartoons, and they get to make music in Scratch, and it feels creative and it feels easy, for low values of easy. In secondary school, the most exciting thing that you will have them make is a program which can sort 8 numbers into numerical order. Yay. No? Okay, so, what happens? Partly it's that we take the fun out of the functional programming, I think. Our friends at Ofsted, normally that gets a cheer, never mind. Okay, our friends at Ofsted acknowledge that it's not easy, that programming constructs are hard, that you also have to learn the syntax, we've talked about this, and you also have to think about how to solve the problem. And There are many, many papers out there which provide empirical data that sticking with blocks longer really does help. This is a nice one. It explains why blocks is helpful. Learning program vocabulary is hard. Blocks simplify that because you can see the words on the block, yeah? Code is hard because it presents high cognitive load. Blocks reduce the cognitive load because you have a smaller number, they say, of meaningful elements. I don't know if that's necessarily true. You also make loads of mistakes when you're typing code with blocks, less so. Controversial view, but there is empirical data behind this. I don't know how reliable this is, but it turns out that girls and boys do just as well in programming tests when they're given blocks as their medium of coding. When you move over to Python, the girls in their study, not all girls, scored lower at this point. I'd like to have more studies, replication issue here, but if that's true, then that really raises issues for how we're teaching programming in Key Stage 3 and why we have such issues with keeping girls carrying on with programming into Key Stage 4, yeah? Do not assume that this is fact, okay? But it's an interesting study, really is. Okay, onwards. So yeah, this is cool, isn't it? This is nice Scratch programming, yeah? I can show you the game. Tom, I'm not going to invite you up because you thrashed me at Pong last time you and I played a computer game together. Here we go. So we've got a spaceship. Come on. Keyboard control here. There we go. We can turn in the thing. Oh, I'm going to lose off the screen. Anyhow, I'm not going to play this in front of you because that's embarrassing for you and for me. That's pretty impressive coding by the age of 11, I would have suggested, yeah? By the age of 13, this is probably about on track for a flight path or whatever. If that's the sort of program you have kids writing in Scratch, do you see any problems that that presents for the transition to coding in Python? Tell me.
You could look at that in a week in Pygame.
Sorry?
Try it in Pygame with
Yeah, and I can do it in Pygame, or rather I can get an AI to do it in Pygame for me, but I'm not going to do that in Year 7. Because object orientation comes a load later, and I can't easily talk about Pygame until I've done OOP. So there's a sequence to this. Yes, sir?
But there is no sequence. Well, there's only a sequence within the block.
Yes. This is not what a good Python program in Key Stage 3 or Key Stage 4 looks like. This is all over the place. I can click on a green flag, and that happens, and that happens. You try getting parallel programming working in Python without Googling it. All right? I mean, it's possible, but I can't remember how to do that. I've got one program here which broadcasts a message which this one picks up, so I'm passing messages between blocks of code. I've got something which is about I start as a clone, and I've got no easy way of explaining what that even means in Python. I've also got loads of events here, each of which runs its own sequence of instructions. This is not how they will program in Python, so there is an issue. If they've been taught how to program in Scratch to that level, suddenly they've got to forget loads of things they have learnt. Makes a really good game when it comes to now put these 8 numbers into numerical order, because that's not how we do it when we move over to Python land. Okay. So, counter-arguments? Yeah.
If that's the issue, because obviously I'm primary and I'm...
It's not obvious, but it's good to have you here. Right, okay.
It's just, so I think though, then that needs to address, if that is the issue going there, do you not think that as primary practitioners and as training primary practitioners should be addressing that issue with the way that blocks are doing and how we do blocks instead of doing it in isolation?
Our friends at, I think, Ofsted would like, and certainly the former Education Ministry would have liked, primary teachers to see their main job as preparing kids for secondary education.
Then you have a problem.
Yeah, you have at least one problem, but do you want to just say which one you have in mind?
The teachers don't know how to code.
Oh,
And they don't.
no, and yeah, we have good resources available, yeah.
Teaching scripting
Yeah.
is much harder.
There are ways of teaching Scratch, which avoid this obstacle. And we can do that. We can restrict our experience of Scratch in primary school to something which will make it easier to transition on to proper programming in secondary school. And so there's a lot of mileage in that. If you accept the government's view, or the former government's view, that primary school is to prepare kids for secondary school, I'm not sure that that's all primary school should do, you know.
And is like there seems to be, I'm don't know, are you all secondary? You mostly secondary? No. I think what happens
We're still nice
is that
people.
sometimes there's this divide, and and it's, we need to support one another. And I think this is, if we understand it on a primary level of what it actually is, then we can support secondary.
So I think the worst possible situation, really, is a really good primary school computing teacher gets her year sixes to the point that they can write that sort of game in Scratch. Then the secondary school academic computer scientist comes in and says, you're teaching Scratch wrong because this makes my life harder. They've learnt bad habits in Scratch. No, this is perfectly reasonable Scratch programming. Just because you can't do it in your proper grown-up computer programming language doesn't mean that I should change my practice, is my view. But other people are welcome to disagree. Maybe in half an hour's time we will have the argument about this. But there is an issue there. I do want to move on and show you the cool toys, but let's just look at the other side of this. Year 8 blog post. I love that Year 8 blog publicly, and I could get a quote from a Year 8 girl that I have never met. But is this not an experience? We said back in 2012, the ICT curriculum is just death by PowerPoint. No, now it is death by Scratch, I'm afraid. We've just taken one visual environment and replaced it with another one. And, where is the progression in this? And if all that Year 8 Scratch programming is mucking around with the design of the sprite, then perhaps we should be doing something else. And, there is this issue that if you just let them play in Scratch, they get it wrong a lot, that somebody needs to come in and, I don't know, teach them how to do this. Mitch tells the wonderful story, sorry Tom, of the girl who's making the basketball game in Scratch. Really, really nice thing. The click on the thing and throw the ball into the thing and then keep a score. And the way the girl was keeping the score was having the scoreboard sprite, change its costume. So it was in costume 0, then the event changed to costume 1. Event changed to costume 2. Really creative solution to how do you measure the state over time that the system is in. And of course Mitch sits down with her and says, let me show you this thing called a variable because we've solved this problem. And it turns out computer scientists encountered a similar problem of wanting to store data in some sort of persistent way. But nobody had ever shown her that. And despite the blocks being there, she'd never sort of clicked those and experimented enough to find the thing. So yeah, the Scratch programs, when Felian and a colleague did the analysis, a lot of the programs on the Scratch repository are not particularly good programs. Yeah, I'm not saying all of the programs on GitHub are particularly good programs either, but it probably has more consequence up there than down here. You also have the current national curriculum, not seen any notifications on the phone about there's a new one, that requires in Key Stage 3 that at least one of the languages has to be textual. The more observant amongst you will have noticed when I showed you that Scratch program earlier, inside the brightly coloured blocks were words. Yeah? Scratch is a textual language. Yes, you can't just have empty blocks. Well, no, you can't have empty blocks, yeah? And, okay, there's nobody from OCR. I've got competing exam boards in the room, yes? So if you are doing OCR, your head of centre, I think that's your head teacher, has to tick a box on a website somewhere to confirm the veracity of this statement, okay? This is how OCR ensure practical programming. Other boards are available. So they say, the head teacher says, the centre has given candidates the opportunity to develop programming skills during the course of study, allow candidates to develop skills to design, test, and refine programs using a high-level programming language with a textual program definition. And we have particular examples of what counts, either to a specification or to solve problems. As I say, there are words inside the blocks if you look carefully enough. The lawyer, centres are required, that's the word in bold, to give candidates the opportunity. Over your summer holiday between year 10 and year 11, you might like to do some practical programming. I've given the opportunity to them. I've not taught them anything, but I have provided an opportunity for them to learn that. Okay, did anybody actually read the Ofsted Research Review on computing? Hey, well done, both of you. That's really impressive. There aren't prizes. As you heard earlier, there are no prizes. So there's this paragraph in the Ofsted Research Review. Although block-based languages may help novices to overcome difficulties with syntax that they can face when learning to program, they do not necessarily help pupils with the semantic and conceptual difficulties. It's therefore important that if schools use block-based languages, they consider how to design the curriculum to mitigate these potential pitfalls. Fairly persuasive argument. A naive reading of that says blocks are harmful because they don't help with semantics. If you actually click footnote 65, did either of you do that? Okay, so click footnote 65 and you get this paper. And the paper says the semantics are hard. The semantics are hard with text and with blocks. It's not that blocks make the semantics harder, it's that the semantics are already very hard. My argument is, if the semantics are that hard, making the syntax that little bit easier might not be entirely against the rules there. And then again, these people, it would seem logical that knowledge pupils need in order to make progress should dictate the programming languages that schools choose for them to learn. This is not always true. A 2009 study of curriculum across 7 countries found the opposite. We expected that curriculum would drive teachers' motivation for selecting languages. Our results discover that this isn't the case and that student-driven factors motivate selection. The inspectorate seemed to express a degree of surprise that in 7 countries, teachers seem to put what's in the pupils' best interests higher than what's actually on the curriculum. Put your hand up if you share their surprise. Okay. So, and then Mark Gudstyle, who knows about all of this, chips in and says, actually, Ofsted are wrong on this one. Yeah? What matters is the learning and engagement appropriate for each student. So where we started with, move them from blocks to text when they're ready, does not seem an entirely crazy way of proceeding with this. Yeah? Child-centered approach, not in order to do the GCSE or in order to do A-level, they need to know the Python. And then there is this. Real coders don't use blocks. You know, is this about preparing the next generation of software engineers? Maybe, once upon a time, that's how we saw it. But I think the whole vibe coding thing kind of means that actually real coders these days, you know, what does that even mean? And, you know, my friend Tom there says, actually there is this, what is it called? Power Design or? Power Automate in Office. It's a block-based language for automating loads of stuff in Office 365. And this is used by important people in business or some such. So, yeah, there are things.
It's very, very powerful and very, very block-based.
And Turing complete. Any problem you can solve, you can solve.
Yeah,
I'm a real coder. I'm a software engineer.
You're still welcome here. It's all right. Amongst friends.
Scratch, because I found Scratch amazing to hone my skills even more, because we get so used to these high-level languages that can do everything for you.
Oh.
And all of a sudden you go back to Scratch and you go, I want to solve this problem. How can I solve it?
Yeah. I have this thing about creativity flourishes under constraint. That if you remove, I remember being given like a box of crayons which had 144 colours in it. Just give me the black and the grey and then see what I can make. And that, it won't be as colourful. I guarantee it won't be as colourful, but the creativity that goes into that might be more significant. Okay, 20 minutes. Anybody actually got stories to tell? I heard somebody saying they used EduBlocks. How do you move your pupils somewhere in Key Stage 3 from working in blocks to working in text?
So we use the EduBlocks curriculum.
Yep.
And Joshua something is the boy who created it. Lo, I think is his name. Lo, yeah. And so he created a curriculum for 6 weeks. We adapted it slightly so it would work. It would work to transition students from blocks to text if they'd already started Python programming in year 6. So they have the hybrid option of being able to either code in text or either code in blocks. We'll
Interesting.
show it in
Yes.
blocks,
Yeah.
and what's really
Give them the
nice
option.
about the curriculum resources is it would also show you in Scratch how that could be implemented.
Yes.
All relatively simple tasks, but you could actually see, so the students that had learned Scratch could see what it looked like in Python and also in the edgy block format. So that was so useful, and then in year 8 we moved them onto predominantly text-based.
Yeah.
But some of our classes, we say, oh, do you remember when we looked at edgy blocks? Would you like to use edgy blocks?
Oh, yeah. This is a differentiation thing, or adaptive teaching, as apparently I now call it.
Yeah.
Yes, sir.
So I'm only in ITT this year, but I've been doing this academic guest.
Yeah.
So when I was going to schools, rather than giving them an IDE, we got them to pseudocode in a text pad.
Wow.
The big problem was the IDE gives you these red squiggle error messages.
Yeah.
When actually, if you were to do the pseudocode, you'd get the mark in GCSE, you'd get the right concept.
Yeah.
So it was really about saying, okay, why do we write this code? Don't worry about the language, the syntax, or anything else, just write the code. And then we'll mark it, peer mark it.
And with your vibe coding thing, that's really interesting, because if I write messy pseudocode, convert this into a Python program, am I coding? It doesn't feel quite the same as make me an app to do this, because I've written the pseudocode and then saying, turn this. Yeah.
For 40 years, and when I graduated from university, only 6 languages in the top 50 of recruited for languages existed, right? And the point is, if you teach a young person how to do coding in a language, that language isn't going to be the one they're using very time.
The version I heard was a good software engineer can write Fortran in any language.
Exactly.
Okay, let me move on. Okay, because there is time pressure. I love this particular task. It's a nice computational challenge. Write a program to work out the smallest set of coins to make these or any amounts of money. We could spend a little bit of time doing this, but I am going to move on. So how would you do this? What's the smallest number of coins you need to make 28p? Quickly. Or slowly even. I think it's 4. Do you want to tell us your 3?
No.
Okay, right, okay, right, yes. And I'm using Royal Maundy for this, yes, okay. So, this, and everybody's got an algorithm in their head, and we could translate that into pseudocode or into Scratch code. My point is that writing it as a Scratch program is a very different sort of programming in Scratch than make Space War in Scratch. This feels like proper computational thinking or grown-up coding. This is not about making something fun anymore. This is very, very serious now. And what I'm doing here is implementable in Python. It's directly implementable in Python, unlike the Space War game. And we can write a version of this in Python if you want. I will show you the thing running. This one is working on a slightly different set of coins. So I'm using, I don't know, I think I'm going to call Bitcoin because I'm using binary values for that. There's a brand there. There's definitely a brand there. Okay, so, and you get to see the cat pooing out coins, which is always a treat for teenagers, isn't it? So, we had 28p earlier. If you had just binary values, what would be the coins? I think it's going to be a 16 and an 8 and a 4 maybe. So let's run the code and see that happening. Click the tick. Yeah, go on. Okay, do I have to press? Something is trapping that. Okay, well, it's not going to work. Refresh the browser. Run the code. See, that's what happens if you try and do a live demo. 28, 16, 8, 4, and the cat's pooed those out, which was what we thought the answer was. I think this is a really nice way of teaching denary-binary conversion, because they know how to make change, or at least this year they know how to make change. Sooner or later, there will be no coins, and it's all just going to be on plastic, so we will have to find another way. So choosing the right Scratch problem is part of this. Anybody used Snap? Of course you have. You know this well. Snap, can anybody see the big difference between this and Scratch? You need to look carefully. Yes, miss? I'm certainly doing something which Scratch gives me no block to do. Yes, there is something I think more fundamental here. This is, can you guess what's in Miles's head? This is not an easy game to play. The report block, here and here, yeah? I can't make a function in Scratch. If I want to make a function that returns a value, I need a different block-based language. And I was once a mathematician. For me, functions are central to all of this. So I'm much more on the church side of the church-Turing thesis of everything is done with lambdas. So, I want to move on to functions, lay the ground for functional programming later. I can still do it in a block-based language, but I can't do it in Scratch. Done nothing scary, not moved away from blocks at all yet. This is called Snap. Sorry. And we have more on Snap. That is written, Eckhart Modrow has written, this really deep introduction to computer science using a block-based language. Snap is what they use at University of California, Berkeley for their CS for All undergraduate class. So CS 50 at Harvard. Berkeley has Beauty and Joy of Computing, which is validated in the States for their CS Principles course for advanced placement. So proper grown-up programming, but still in a block-based language. Lot of time for that. This slide. Okay, here you go.
How do I represent?
You don't know how to represent it. How would you want to represent it? How would you want to represent it is an excellent question. Okay, let's have a go. Let's have a go. So I'm going to do... Sorry? See, that's why I give him a place at my university. Actually, somebody else gave you a place at my university. Yes. Okay, so you're way ahead of me. Shall I do this from scratch? We have 12 minutes. I'm going to show you the code for it. Okay, let's just get rid of that one, because that's a bit more interesting. So this is where I favor a prim rather than a live coding approach. Because if I just show you that program on screen and say, predict what this is going to do, unless you're as smart as Tom, you get nowhere with this, okay? Because you think it's going to move a dot across the screen, which, broadly speaking, it is, yeah? We run the code. A pixel lights up. Press button A again, another pixel lights up, and now the people who said it's going to move a dot across the screen are feeling very, very smug, yeah? And I press the button again. Oh, that's not quite what I was expecting. And that's definitely not what I was expecting at that point. So what you eventually see is that these are the binary values of that. Why am I showing you this now? Because the wonderful people at Microsoft who made Make Code have the Python version of this at the click of a button. So this is like where we get to with Python in pieces. This is microbit based. So I've got the blocks here, and I've got the Python here. And then on a good day, I can take all of that onto my clipboard, paste that again underneath. Oh, look what I've done. I've done bad formatting. Oh, that's okay. It's complaining that I'm using the same function version named twice, but that fixes it. And then instead of, well, lead point, I'm going to have while not. And I'm going to change that to plot. And I'm going to change that to unplot. One more thing to do. Take line 15 there, copy that, paste that in. And I have on button B pressed, run the function called on button B, on pressed B. And now I've just extended my block-based program by copying and editing the Python version of that. Click the play button. Button A works just as you've seen. Button B should now count me back down again, which is quite useful because it will stop. And of course, in answer to the question, what's the biggest number I can store on a microbit screen? It's not display. I'm not keeping this number in memory other than on whether the LED is lit or not. There is a device abstraction layer running here somewhere. This is actually it's a visual representation of a bit of memory that I'm looking at here. There you go. And, for those of you who are interested in the history of it, anybody remember the Williams-Kilburn tube? Early computer memory, cathode ray. You light up a dot on the screen using electron guns. You have then photosensitive cells which tell you whether the dot is lit or not. This was one of their first attempts at making computer memory. You stored it as light on a phosphorescent display. If you've got one of those in your cupboard in your IT room, come and talk to me afterwards, please. We'll make you an offer for this. Okay, so you've seen that working. And the technical term, just jot it down if you want to bring it into conversation tomorrow, is bidirectional dual modality. So I've got blocks and I've got text, and I can move in either direction between them. And we have studies. Look, there's a table of values here. Blanchard, Gardner-McCune, I know Gardner-McCune, Anthony, 2020, did the experiments about this, and they found that this being able to move from the blocks to the text and from the text back to the blocks was very, very powerful in scaffolding this transition from one to other.
I remember us having a debate about flowcharts and algorithms and why because I was pitching and saying that you should perhaps flowchart first or put pseudocode first.
Yes, I hope you've learnt the error of your ways now. But carry on, sir. Yes.
But I was talking about the platform Flowgrid.
Yes, yes.
Because you can plot out a flowchart,
Yeah.
and then the students can have a look at that code, in a code version, looking at Python, Java, whatever the other programming languages, and it makes a really good link between the two.
Yeah.
You get to be able to see it. So this feels sort of...
It is very similar.
Yeah.
I like being able to run code in block languages, and it's hard to run code in flowchart, although Flowgrid does it. And you and I both know that these days the kid who takes a photograph of their flowchart and says to the tame AI, make me Python from this, job done. We're there, aren't we? And you have classic examples. This one is often used in the literature. Accept input temperatures one at a time until -999 is entered. Calculate the average of all the temperatures before that. I can do this is EduBlocks that you're seeing here. So this is a reasonably good job at doing this in EduBlocks. Though I, of course, want to use break in my implementation of this. Notice you have to do the typecasting, and that's not obvious to the kid who's grown up with Scratch, because Scratch doesn't require you to say, convert this string input into an integer. One of the gotchas to watch out for. And then EduBlocks is very, very good at showing me the equivalent Python code. EduBlocks is unidirectional dual modality. I can write in blocks and see the Python code and then run the program. But if I attempt to edit this, it says, oh, you think you're a proper programmer now, do you? And takes me out of the block-based environment, which if I was a kid, I would find really annoying, because that's like a software engineer has stopped me doing it. There are good reasons, because you have to represent it in a block, and everything that you can represent in text may not have a matching block for it. So, this thing about we move them on when they're ready, you move on into text when there are no longer enough blocks there for your idea. Church-Turing thesis, Bone-Jacobi theorem notwithstanding, and all of that. And Becky has asked me very much to mention CAS is on the case about this, and CAS is now going to have a set of resources which help with EduBlocks. And from what I've seen, I wasn't one of the reviewers, not looked at these in detail, they're pretty good. So really simple. No, simple? No, none of this is simple. Not for a teenager. There are some nice programming challenges here, and then they have the task of make the EduBlocks version look at the Python code that corresponds to that. Some of them, I'm sure, would be only too happy to race ahead into the Python code to get something like that working. And then I want to, because we have you here, I want to talk about two simples. Wonderful Python in pieces, which has the bidirectional dual modality to it. So whereas make code for the microbit does it in both directions for the microbit, what TwoSimple have done with Python in pieces is do this as like a proper on-screen IDE for writing Python. I'm not going to do the live demo from scratch, but let's have a look at, here's one I prepared earlier. So you've got a block-based program on the left there. You have the text-based equivalent on the right. Watch what happens if I change this number from 10 to 12. It changes immediately on the text-based version of that, which is pretty cool, and we can do our tables test here. 11 plus 8, anybody? 19 with a bit of luck. Look at the bottom right of my screen as well as the bottom left, and you see we've got a trace table running there. It's showing me what value each of these variables are, which I think Thonny does, but yes. I've not seen this in many other secondary school age IDEs for Python. So respect. I think you did a good job with that. And then, stop. No. Then I can do more of the interesting stuff. So if I want to make this a times tables test, and obviously we go up to 12/12s because we're thinking about what happens when reform win, and they take us back to imperial measurements. So I think that's going to give me a tables test. 10 questions, not nearly enough. Let's do a 20-question one. And then, what is 6 times 9? 54. Ministers never answer that question. 6 times 9 is still 54. Okay, 9 times 4. I thought there was a glitch. Okay, it's just freaky coincidence. What are the chances of that? Well, 1 in 144 or something. I'm not going to do the rest of the tables test in front of you now because you know what would happen. And I like the fact, did I show you that you could move both ways? I did show you that you could move both ways, which is really very nice. So anybody doing any universal design for learning? Anybody? Okay, it's another TLA, isn't it? UDL here. So the notion is you have multiple ways of getting the kids engaged. For those of you working at Key Stage 3, you saw my graph, you know what an issue Key Stage 3 engagement seems to be. You have multiple ways of presenting the content, the big ideas here, and then multiple ways of them to respond to this. So I want everybody to understand about lists. There are lots of ways of teaching about lists. I can do shopping lists, I can do football teams, I can do just integers. I can introduce lists in lots of different ways. Not all of these are going to be equally engaging for all teenagers. Find the one that works. Yeah? And the multiple ways of response, does it matter if your learning objective is to be able to iterate over a list and update an accumulator? Does it matter if you do that in Python or if you do that in Scratch? What's the important thing here? Is it the construct or is it the expression of this? And Universal Design for Learning says, look, get a life, folks. It really is the idea that matters. If some of, I know, what can we do? If some of them want to respond in a text-based language, if some of them want to respond in a block-based language, are you going to give a lower grade to the ones who've used blocks? Their program works if it does what you ask them to do, but they happen to use Scratch or Snap. Does that really deserve a lower grade? I don't know. Right, there's an interesting conversation for you to have with your colleagues when you're back. And then let me quickly, because you're missing out on Neil's excellent talk because it was scheduled at exactly the same time as mine. So I love turtle graphics. My conversation, and I missed the first 2 sessions because I was working with curriculum developers elsewhere. And my conversation with them, they say, no, we're doing turtle graphics in primary school. We can't possibly do turtle graphics in secondary school. I say, that's exactly where you have it in both, because they know the turtle, because they've grown up to love being able to draw shapes. And yes, they started drawing the shapes in a block-based language, but now let's draw similar shapes in a text-based language. We take the semantics, we don't have them worry about the semantics, so they can get to grips with the syntax. And I think if you want them to move into text, then moving into text is not an entirely crazy idea. And I was going to show you something in Stripe for this. Let me do this from scratch, no pun intended, because it is quite nice. It takes getting used to. Never do this without practicing it and getting used to it. I'm going to make mistakes here. I'm going to import a library, so I press, there are 4 keys I am allowed to press here. I can do I, L, or F, or a hash symbol. I never use the hash symbol in my code. Anybody else? No. Okay, so I do the F from turtle, import all of the whole thing there, yeah? I can now tab down, or I can move into this block here with a cursor. I'm going to delete that, and I'm going to delete that. And now I'm going to write some code. Again, I have a limited palette of keys that will work at this point. I can press the space bar, I can press an equal sign, or I can use any of those. I'm going to go with an F for 4, and it fills in the gaps. It's not like Scratch, but it's not like Python either. It is Python. It's not like typing Python. For I in range 4, do the following. And now it's really tricky because I want to say forward, but there is no obvious forward here. So this is a function, strictly, I guess, method call, forward. And we'll go forward 100. And then I'm going to space again, turn right through 90 degrees. And that should give me something which, anybody like to predict what this program is going to do? Right, we've seen this one before. Ta-da! All right, so we've got that. And then, of course, I can go off and do the sort of thing I love doing in Turtle Graphics. So I can have for I, j, I guess, in range, let's do 10, 10. Drag that block into there. And then after that block, I'm going to have space right through 36 degrees. And I think to save you all from the agony, we're going to set, oh, look, I made the mistake. Because you're only allowed to press the keys. You're given space for a function call. Speed 0 should make it run as fast as it possibly can. I hate doing these live. Right. And then we get the crystal flower out of it. Yes, you can do it in Scratch. Of course you can do it in Scratch. But I think it is easier to do it in Stripe than here is a blank text editor. Write your program. I can give them the skeleton code, but I can also not give them the skeleton code. Right, we are out of time. I did say vibe coding. So here in my VS Code, I gave it the SB3 file for that Scratch program I showed you at the top, the Space War game, and then said, can you convert this Scratch program into Python code? And it is very, very happy at reading an SB3 file and producing the Pygame equivalent of this, which with a little bit of luck, we see on screen there. Oh, right. There we go. All right, so that idea of I've written a program, I've got an idea of it, I like that way into. I don't think it is just make me an app. I think I've done a lot of the thinking still, but the actual expression as code I can outsource to a machine. I'm sorry I've taken so much of your time. If you want, there's my email address and there's the URL for the slide. It's been lovely to have you with me this afternoon. Thank you so much for coming along to this. Thank you. Thank you. Good. Somewhere there's a tape running here.